so if you split the middle, you pull out what they have in common, x squared. You have x plus 2 left. You want to have x plus 2 in common as well, so pull out a negative 1. Okay, so that means you have x plus 2 all the way out front, and you have x squared minus 1 left, which is x plus 2 times x squared minus, or sorry, x plus 2 times x plus 1 times x minus 1. So that's your denominator. I'm going to erase my long division so I have more room. Okay, so I have x plus 2 as one of my denominators. I have x plus 1, and I have x minus 1. They're all linear factors. So I have a, b, and c. Okay, here's where it gets tricky. For a, you need to multiply it by x plus 1 and x minus 1. So kind of do a little bit of this in your head. So I'm going to have a times x squared minus 1, yep, plus b, I'm going to multiply by x plus 2 and x minus 1. So think about x plus 2 and x minus 1 in your head. It's x squared, your outer is negative 1, your inner is 2x. Yeah, so it's b times x squared plus x minus 2, good. And then plus c. C, I would need x plus 2 and x plus 1.
X squared plus 3x.
Yep, x squared plus 3x plus 2, thank you. Okay, that whole numerator equals this numerator here. See how these can be annoying?
This will be fun.
Yeah. So we have ax squared plus bx squared plus cx squared. That's going to equal, oh, not that numerator. It's not that bad. This numerator.
Do the other one.
Yeah, well, we've already simplified. Okay, so we have a plus b plus c. Those are going to be all the things with x squareds. That's going to equal 0 because we have no x squareds. Okay. How about x's? What am I going to have for x's?
B plus 3c.
Yeah, bx and 3cx. So b plus 3c equals 5, right? Because it was 5x before. All right, and then my numbers. I'm going to have negative a minus 2b plus 2c equals 7, right? Not very nice, is it? Yeah, you can use matrices on your calculator if you know how to do it. Do you guys know how to do that? You can do that, or you can do it by hand.
Can we just add them all together?
If you add them all together, you're not getting things that cancel, right? Oh, actually, yeah. Yeah, that does work. Do you guys see what Brian's saying? If you add straight down, this is shifted over a little bit. A's cancel, so I get 0. B's become 0, so those are gone. C's, I get
6c.
6c equals 12. So C is 2.
Yeah.
Oh my goodness.
Once you have 2, so that goes in here.
So b is negative 1.
So B is negative 1, right? Good. And then A, negative 1. Okay, we got them. So that's your final answer. That wasn't bad. All right, so negative 1 over x plus 2 plus negative 1 over x plus 1 plus 2 over x minus 1. That's your partial fraction decomposition, which is very easy to integrate.
You forgot the 2x. Give me a point. Come on.
What do you mean I forgot the 2x?
1 at the
2x.
beginning, 2x plus all that.
Oh, 2x plus, yes, you're right.
6 points. Come on.
Is there a sheet yet?
Come on.
George doesn't get any points. He already met his quota for the.
Oh.
He's a point per Anna. All right. How much time do we have?
We're done. Wait.
4 minutes.
Get your clock says we're done.
Okay, do you guys all know how to integrate these? Do I need to do the next part of it? The actual calculus part of it? So it says use partial fraction decompositions to find the antiderivatives of A and B above.
Why?
So is this the thing that we're gonna end up doing all the time?
Yeah.
We've been working on it.
Okay, so what was A? Let me just explain it real quick. So A we found to be 1 over x minus 2 plus negative 1 over x plus 2. So you're going to integrate that. And then B we found to be 1 over 2x plus 3 plus negative 3 over 2x plus 3 squared. Okay, so let's integrate this. Okay, so this first one you can break into two separate pieces. So I have 1 over x minus 2 dx minus 1 over x plus 2 dx. Okay. You can do a u substitution, but see how du is just 1 anyway? So it's like you're saying u is equal to x minus 2. So you're integrating 1 over u, which is what? Natural log. So you'd have natural log of the absolute value of x minus 2
They say we can't do that.
minus, what do you mean you can't do it?
Just do it.
ln of, this will be the same kind of thing, and then plus c. That's it. Yeah, what I was telling you on your homework is you had this. You had this, George, on your homework. And you tried to say it was natural log of 4x. If you did a u substitution, you'd have a 1/4, right? So you got something. I would just pull out the 1/4, and you have 1 over x. Yeah. Okay, now this one, break into two pieces. This one you could let u equal 2x plus 3. So du is 2x. So that means 1/2 du is equal to, oh, not 2x, 2 dx. So 1/2 du is equal to dx. Okay, so on this first integral, you would have 1/2. You'd be integrating 1 over u again. So it'd be natural log of 2x plus 3. How about the next one? U would still be this. So I'd have you'd have the negative 3. You'd have 1 over u squared du. How do I integrate 1 over u squared? U to the negative 1 with a negative 1 out front. So it's minus 3 times negative 1 times 1 over 2x plus 3. And then plus c. And you can clean that up a little bit. Just have plus 3 on the top. Okay, that's your answer for that one. Okay, so that's not too bad. Once you do the partial fraction,